Hello, and welcome to the Data Engineering Podcast, the show about modern data management. If you lead a data team, you know this pain. Every department needs dashboards, reports, custom views, and they all come to you. So you're either the bottleneck slowing everyone down, or you're spending all your time building one-off tools instead of doing actual data work. Retool gives you a way to break that cycle. Their platform lets people build custom apps on your company data while keeping it all secure. Type a prompt like, build me a self-service reporting tool that lets teams query customer metrics from Databricks, and they get a production-ready app with the permissions and governance built in. They can self-serve, and you get your time back. It's data democratization without the chaos. Check out Retool at dataengineeringpodcast.com/retool today, that's RETOOL, and see how other data teams are scaling self-service. Because let's be honest, we all need to retool how we handle data requests. Your host is Tobias Macy, and today I'm interviewing Shilpa Kolhar about using MongoDB as the foundation for AI-driven applications. So Shilpa, can you start by introducing yourself?
Hello, everyone. I am Shilpa Kolhar. I am SVP of Product and Engineering at MongoDB, and I'm currently focusing on Application Modernization Platform.
And do you remember how you first got started working in data?
Yeah, I think my involvement in data management was, you know, an inevitable destination, given that I spent about 19 and a half years of my career at Google building ads, GCP products, and more recently working on, before joining MongoDB, working on Google's core data infrastructure, where I led teams that built Sawmill, which is Google's logging infrastructure, deals with exascale data, which is exponentially growing, Napa, which is Google's core analytics data backend, and we also built ML data store, which was the backend that had all of the pre-training data for both classic ML and also for Gemini and Gen AI use case. So it felt like I spent 19 and a half years working on scaling the data infrastructure, working on making data available for different use cases, be it ads for monetization, building products from 0 to 100 with display ads, remarketing, Gmail ads, and so on, and also handling data with a lot of love and giving utmost importance to data safety. And that experience of mine actually led me to MongoDB, my current role, where I would like to bring that scale and that rigor to every developer and the community that has leveraged MongoDB for their applications and are working towards building their next generation of AI applications and AI agents on top of a solid unified data platform like MongoDB.
And you mentioned that your current role is focused on the Application Modernization Platform, which I've seen abbreviated as AMP. And modernization is one of those terms that means different things depending on who you're talking to and in what context. And I'm wondering if you could just unpack that a little bit as far as what the focus of that initiative is within the context of the Mongo platform and ecosystem.
Yeah, I tend to agree with you. Modernization has different meanings, and I know there are a lot of people looking at modernizing their applications. So, our focus with Application Modernization Platform at MongoDB is to enable the enterprise customers who have been stuck with their legacy applications on legacy relational databases to move on to MongoDB. And this transition is not just an application level change. It's not a lift and shift. It's not a replatforming. We are looking at re-architecting because it's a data model change. When we move from tables to collections to document model that MongoDB is built on, it's a data model change. It's rewriting, or I'd say code transformation as well. Like you analyze the application, do the code transformation, the data modeling, schema changes, and then finally getting it to be deployed so that the customers are able to leverage MongoDB as their data backend. So our goal is to get customers onto MongoDB, be AI ready. It's not just about like, okay, take it 1:1 convert the functionality as is, but bring in the good practices and good design patterns that we have seen more recently onto these applications that have been modernized.
And you also mentioned the growth of AI and agentic use cases and the need for having that shared context layer, shared data layer for those use cases, and how much of this initiative for that modernization enablement is built around that need, or at least perceived need, for organizations to be able to start building out more of those generative and agentic capabilities.
Yeah, that is an interesting question. So if we look at it, right, historically, people have worked on modernization, back in the 2000s, then 2010s, and so on, where it was like, oh, modernize by moving to cloud, right, or modernize to break your monoliths into microservices, and and in the past, everybody's goal was like, oh, if I modernize, am I saving costs? Or like, cost was a major factor. But now, if you are if your data and your business logic is stuck in the legacy system, then you're not able to leverage the new agentic AI enabled features. You cannot build that easily on top of these stacks. So I have seen that as the driving factor, but cost is still one of the driving factors, and for modernization. So it's not like it's gone; that's still there. And with AMP, we are working on actually, the speed to modernization. That's our top goal, instead of the traditional way that SIs do, where they take years to solve the modernization problem. We are looking at order of weeks to months to actually do projects which would have otherwise taken 2 to 3 years. Now, your other question on, okay, what, when we are modernizing, when we modernize on MongoDB, onto MongoDB, that natively gives the application ability to change much faster, because the data model at the DB layer and the data model at the application layer is the same. So if you have a user profile that you are working on, that the application layer is working on, or the agent is looking at it, it's the same user profile that's also stored in the DB. So any changes to this is much faster. So natively, MongoDB supports change much faster with lesser technical debt. And that helps not just through the modernization process, but also once you modernize, you are like better equipped with change. And in this AI world today, we know that the one who can change fast is the one who will succeed. So, that way, the native JSON document model, which helps with faster change, is been a critical motivating factor for many of our customers. And then the other thing that not recently, last year, acquired Voyage AI with world class, best in the world embedding models. And now we are looking at data not just as operational data, right? It's operational data, contextual data, um, having search built on top of it, the right embeddings on top of it, where there could be multimodal data mixed in together, which will then enable your uh, new agentic AI applications that you could build on top of it.
Digging into that vector embeddings and the search and retrieval aspect, that is one of the interesting outgrowths of this introduction of generative AI, is that there has been a massive investment in that as a core storage and retrieval capability that has led to the growth of vector databases as their own distinct category, as well as virtually every storage engine under the sun adding some form of vector storage and indexing. And I'm wondering if you can talk to some of the aspects of MongoDB and their implementation and how they compare to that broader ecosystem of the investment that's happening, where you have things like Quadrant that is purpose built for vector storage and retrieval. You have Weaviate, ChromaDB, Pinecone, I think, was one of the forerunners there that even predated the introduction of ChatGPT. And just wondering if you can talk to the primitives in MongoDB that allow it to be competitive in that ecosystem.
Yeah, so I think what MongoDB provides is a unified platform a platform where your operational data, your indices, and your embeddings all stay together. So when there is an update to your data set, to your row or a document, then we recently launched auto-embedding, where at the right time itself your embeddings gets updated. So there is no, and your vector search, which leverages it, will be a lot more accurate, relevant, and real time in sync with the data. So the drift that would have otherwise happened, if you, let's say, you have, here is your source of truth, your database for your source of truth, and then here is your vector DB where you move the data from there to the vector DB, and then you have embeddings and search on top of it. There is this drift aspect that naturally comes in with having two different data stores, which gets completely eliminated with MongoDB providing that unified platform. Also in terms of security and access patterns, so like all the standard issues that you see where copying of the data or duplicating of the data, even though that data is in the form of embeddings, like the same issues would happen if there is a separation. Now with MongoDB's unified platform, you get it all together with a very low latency, which is very critical for any AI application, and also it makes it as a good use case for maintaining your contextual memory, because it's a real time transactional and so on. If we look at Retool, Retool recently it named MongoDB's Atlas Vector Search as the most loved and the second most adopted vector DB in the market. And this is helping deliver high quality retrieval and with a greater accuracy that modern AI and RAG applications require.
Digging now more into that document structure as the core representation in MongoDB for data storage and retrieval. As you mentioned, it adds a lot of flexibility in terms of the capability of having schema evolution, sparsity of attributes, the ability to move faster because you don't have to wait for the relational structures to be modified before you can make a change to your data. That can also end up being counterproductive if you're not careful, because you need to make sure that whatever attribute you're trying to retrieve actually exists, or that the data structure that you're trying to operate on has all of the pieces that you think it should, because maybe you wrote a document 6 months or 2 years ago, and then your schema in the application evolved to add or remove various fields and features. And I'm just wondering how you've seen teams address that drift in terms of that schema at the application layer and some of the functionality that Mongo offers to maintain that level of consistency and avoid errors and failure modes due to that lack of oversight or due to the accrual of technical debt.
You're absolutely right. Schema drift, or the when you get freedom with schemas or schemaless, it is a double-edged sword. However, at MongoDB, instead of drifting into this chaos, we have this JSON schema validation in place. So just because MongoDB can support schemaless doesn't mean that it should be schemaless for every use case. So we do have JSON schema validation. It is right at the database level. Think of it like a gatekeeper. You can tell the database, look, I don't care about what else is in this document, but every document, every user document, for example, should have a valid email string and should have a creation date. And you can even set it to, like, you can call it to be a strict constraint, or it could be a warning instead of a reject. And that way, when at the ingestion time itself, because of this JSON schema validation in place, you can eliminate some rows which don't fit in that specific schema to avoid future schema incompatibilities. The flexibility that I love here is, like, you can decide to warn or reject or accept it. Now, based on your use case, you can pick which of these constraints is like appropriate for you. And then the next thing that I love is the schema versioning. Like you said, there is a change in the application layer, or there is a change in the database schema over period of time. Then how do we handle it? And the way developers or application developers who have used MongoDB have handled it is with leveraging the schema versioning pattern. So instead of trying to keep all the documents in the collection in sync and doing this huge data migration or data updates at a time, we have this notion of schema version. And so that way, at the application layer, the application layer can be schema aware. Like, if you pulled a data or a document of v1 record or v1 version of it, then this is what the content of it would be, and for v2 it could be a different content. And then so that way, at the application level, you can handle the schema variation, which gives you time to heal the DB, or to get all of the data sets to be following the same schema or the same pattern. And then we also have these constructs or parameters, like we have aggregation pipeline. So at the exit, when the data is read, you can use constructs like add fields. If a field is missing, like $add fields, where you can set those fields with the default value for the documents which do not have those values. So that way, the application layer always sees a consistent view or the schema of the DB. Like missing fields, nulls can be handled very well with these $add fields. And then last but not the least, at the application layer, you can always handle it through ODM, like Mongoose or Node.js, where they could potentially be that layer where it defines or prevents the schema drift impacting the application.
On the point of the JSON schema representation for the actual storage layer, that's also commonly used as the means of representing APIs available from an application, and is also used for being able to do things like code generation for clients of those applications. And I'm wondering how you're seeing, in the context of that application modernization platform, the leveraging of JSON schema as that shared representation across the different process boundaries, and being able to do code generation and accelerate the delivery of new clients and new functionality, because you have that standard representation that can be used across different language boundaries.
Yeah, that's a very good point that you bring up, Tobias. So, when we are looking at application modernization and when we look at users' code base, especially the legacy code base, there is so much sprawl and chaos, not just at the DB layer, but at the interface level, at the API level, the way the data is exchanged, the way we are handling application modernization, where we actually, you know, do the analysis of the application, analysis of the DB, both runtime and static, leveraging logs and so on, are one of our initial deliverable or milestone or phase is to come up with the right schema recommendation and then have that JSON representation at the DB layer. And this schema or the recommended schema is then a critical input for all of our agents that are doing the code conversion. And we have like naturally, like as you said, with the application development, the API interface tended to be the same JSON as that of the DB layer, especially when people are looking at data transfer between the application layer and the DB layer, and also between the APIs between the microservices as well.
In that context of microservices, that's another one of those terms that has different meanings depending on who you're talking to, where I guess the standard definition is really just that you have business logic that is isolated to a deployable unit, and that deployable unit is some definition of small, where again, that's a very fuzzy boundary depending on who you're talking to and what the organizational structure of the team is. But oftentimes, each of those services will have their own persistence layer, maybe not even the same persistence layer, where maybe you have Postgres in one place, Mongo in another, S3 in a third, another one just uses Kafka queues. And I'm just wondering if you can talk to some of the ways that teams who you're engaging with think about the standardization on Mongo as a means of reducing complexity and reducing cognitive overhead of teams who are maybe working across boundaries of those different services?
Mm, yeah, I mean, I can think of a recent customer example where, they actually had different data backends, data stores, like you mentioned. And that happened naturally because of various acquisitions as well. So it's not just a legacy enterprise customers issue, but even, more recent companies like which were born in 2010s and later have this issue of, and different data stores, not by design but because of acquisition or some such um, path that they followed. So the way we are, when we talk to the customers for application modernization, when we look at it from our point of view, we look at the whole code base, the various databases that exist, and of course their schemas and so on, and looking from the outward and, like, looking at the business goals, we come up with modernization units. Now, yes, I have also seen in the past, you can go too much into microservices where making your, actually, it could end up with your whole ecosystem being extremely complex, because there is a pro and con for going way building too many smaller microservices. So having the right balance is important, and the way we are tackling it is like, okay, creating modernization units upfront. So there would be a modernization unit, let's say if it was a retail company, a modernization unit whose whole and sole purpose is to handle product catalog. And then there would be a modernization unit whose sole purpose of that exercise would be, order and delivery. So we take one modernization unit at a time, look at the various data backends that was used in that modernization unit, and then go from there by migrating it onto, like, modernizing it onto MongoDB. And MongoDB does provide, it's your operational database, and if you want to store your activity data, MongoDB already supports that. If the modernization unit, needs at some point a chatbot, yes, we have the RAG built on top, vector search built on top. So that way, one modernization unit at a time, holistically we move the data from various sources onto MongoDB as we rewrite that application for them, of course still retaining all the, the governance and security needs of those applications.
And for teams who are getting started with that modernization process, what are some of the challenges that you're seeing them come up against as far as either understanding the entire estate that they're responsible for, or coming to terms with some of the architectural evolution where maybe they have a certain mindset of this is how you build things, they've got their set of patterns that they're used to, and just some of the overall workflow of being able to get teams up to speed with how to use a platform like Mongo AMP idiomatically and not fall back into their old patterns that cause them to try and do backflips to do something that is actually just 2 lines of code, and they're actually writing 200 lines of extraneous code unnecessarily.
Yes, there is always a fear of that, going back to old ways. um, so the biggest surprise to me was, not just one, like multiple of the customers that we engaged with, they did not know what was in their code base, or what were the different dependencies that their applications had. And then when we go in and then do this analysis and give them a report, um, they were equally surprised. Because even before we do the analysis, when we have the initial discussion, I'm like, okay, what does your application look like? What do you think are the dependencies? um, when we create that sheet and then we go back, do the analysis, and see what we unearthed and what we found, it's just amazing to see the reaction that the customers have. They're like, okay, we didn't know that we had, you know 500 stored procedures in our Oracle DB. Okay, or we didn't know that, oh, not only we used our we didn't know that our application was dependent on this another COBOL application, or there are like a lot of surprises, and many of the things that they depend on, were probably end of life like a decade ago, and it's still running. And I think that was the biggest surprise that customers had when they first engaged with us, and then when we gave our initial report to them on their application, their code base, and so on. So yes, I think like not knowing the scope of the modernization project is the initial biggest surprise that the customers have. Once we define the scope, I think yes, there is always a push and pull in these large companies, where things evolved based on the org structure and team structure, which might not necessarily be the right design or approach that one needs to take in their new modernized application or whatever is relevant today. So there are some frictions there where people would be like, yes, I want this to be a separate service, or because the team is structured along those ways. So that's why we have our like MongoDB AMP has our team of engineers, forward deployed engineers, who work very closely with the customers to actually get them onboarded onto, okay, what would the new architecture look like, what would the and how could they enable further development and STLC in this newly deployed application, right, in the with the new architecture. And we also, as part of AMP, it's not just the platform that we bring in. These people are working with techniques that we have developed over and over again with multiple different engagements. So the process management, educating the customers, and then bringing them up to speed on how to maintain the new application is something that we have worked on over the last 2 years.
And on that point of architectural patterns, what are some of the best practices or foundational recommendations that you have for teams who are trying to adopt some of the latest and greatest architectural styles, or some of the ways of designing a system and an application that is founded on MongoDB as that storage layer that help to accelerate delivery and allow for further evolution of their functionality and capabilities?
Yeah, so of course, with the document model, we would ideally like to have the collections such that the data that is accessed and worked upon, fit in a single, like one collection. Of course, MongoDB does support cross collection transactions and so on, but it would be ideal to have it in one collection so that all the data that are read and returned together would be in one place, and the application layer accordingly reflects that. In fact, it's vice versa. Actually, application layer actually works on, like, let's say, a user profile as an object, like with all the properties of the user profile in there. Then our data layer actually reflects that. The other patterns that we are, recommending at the application layer, of course, no need to reinvent the wheel. Let's look at the applications being rewritten using Java Spring Boot framework, and we are asking them to standardize on, logging, standardize on authentication, and so on. But not all customers want to change some of these aspects, and we are okay with it. We have that customizations in place for them in case, they uh, like they are doing one modernization unit at a time. They cannot be drastically changing their CI/CD or SDLC for that specific unit. We will nudge them towards a direction, but once we finish majority of the modernization unit, that's when that change will happen.
Another aspect of the AI native applications and agentic use cases that has been gaining a lot of attention lately is the concept of agentic memory and the need to be able to extract and store and retrieve information that is generated through interaction with the system as opposed to things like RAG workflows, where that's largely driven by you have some source corpus that you are explicitly using to create that context layer. You're instead allowing that context to be generated organically through the execution of that application. And I'm wondering how you're seeing teams leverage some of the primitives in MongoDB to be able to power those use cases as well.
Yeah. So when you look at use of MongoDB as agentic memory, so MongoDB is a transactional database. Primitive number one, it provides um, support for both structured and unstructured data as a document model with JSON to add some structure. And then we have, natively, yes, there is RAG, search, embeddings, all natively available on MongoDB, which actually helps in MongoDB being positioned as a backend for context memory. Because the critical thing, as the agent is running, you cannot wait for, okay, I'm going to put in this context in the DB. Then now that is going to further get indexed, embedded, and then I'm going to look up. There's no time for it. Everything has to happen real time, and that's what MongoDB is really good at. And with all of these functionalities, like um, embeddings, indexing, natively available in the same platform, and in the on the same data set, it just makes it like a perfect fit to be both as a backend for short term and long term context memory that is needed for agents. And also the other aspect is, like, today we already support various interactions or various events that happen. And now with agentic AI, the number of these events, and the not only it's the events that happen, but also reasoning associated with it and the context associated with it, which could be not necessarily structured, but it is semi structured. It naturally fits in the MongoDB's document model.
And as you have been working at MongoDB and recognizing that it's still a fairly recent space for you, what are some of the most interesting or innovative or unexpected ways that you've seen Mongo and the AMP use case applied, or just use cases that you didn't envision were possible before you joined?
I'm actually very impressed with the scale at which MongoDB runs and the scale at which the customers of MongoDB. The example that I would like to take is that of Central Reach, which they used MongoDB to unify 4 billion data points for enhanced autism care delivery. I mean, so that's impressive. The most interesting thing in the context of AMP that I have seen, MongoDB being used is, not just as a destination database where you go onto the database with the modern app, you're ready for AI, but also how my team has been able to leverage MongoDB's features, like like the zeroth customer. So AMP is a platform which is built on top of agentic AI and deterministic tool. We are able to leverage MongoDB to be that context memory through our application transformation. And I'm super excited about it, where we can actually see things live in action. We are looking at exceptions that happen, errors that happen, bunch of text which then needs to be added as context back to the build, fix, build, test loop of ours. All of these context going back into MongoDB to actually enable customers to move from elsewhere onto MongoDB. I just love that cyclic amplification that MongoDB is able to bring. And when I think about it, if I were to do modernization, MongoDB is like the perfect database because it naturally supports going an incremental path towards modernization. Otherwise, think of it like, if you were to do it with a relational database, then I need to have my schema in place, because making a change in the schema, change to the table, change to the columns, is end to end, all the way from the DB layer to the application layer and the UI layer, maybe in some cases changes. But then MongoDB natively supports that incremental development. And that is the strength that it brings as the destination DB for AMP. So that helps my team to go one modernization unit at a time without having to rework the previous modernization unit when you work on the new modernization unit. And that's why I say that, when you move to MongoDB with AMP, you are actually set for future. Hopefully you'll not need any further modernization projects, because now there is no accumulation of tech debt. You are naturally evolving and your DB is evolving with you.
And in your own experience of working in this space and joining MongoDB and helping teams come to grips with the problems that they're trying to solve and overcome some of the limitations of their accrued technical debt, what are some of the most interesting or unexpected or challenging lessons that you learned in the process?
Some learnings, I think, is more about the chaos and noise around this space, where yes, AI is awesome. Gen AI helps you in transformation. But then the belief that Gen AI is a magical bullet where you'll throw your code base at the LLM and now you're going to get a brand new application out of the box without having to do any work. I think there is a lot of noise and chaos around it saying that, okay, these are the capabilities, without people realizing that it actually still needs a well thought out process, a well thought out end state architecture, and breaking that problem down into subtasks or sub problems, which of course the LLMs have helped us expedite amazingly. But then how do you leverage them at each step is a learning for my team. It's a learning for our customers, bringing them along, saying that, okay, it's a magical bullet to um, like, here are the steps involved and this is how we can leverage. Yes, it is still awesome. It'll give you we have seen customers code transformation expedited by 60%, and we have seen customers being able to create new workflows and onboard their customers, reducing the onboarding time by 85%. So all of those success stories are amazing. Still, this it's a step by step process. We need to work with, build those right agents, give it the right context, and of course, leverage the awesome models that have been built to do this application transformation. It's not a magic bullet. And then the other thing that I'm also noticing is that there's a lot of variations in the legacy code, so it needs focus. So we got to pick few stacks to start with, build on top of it, and then LLMs will naturally help you you know extend it to other use cases as well. So this still needs that stepwise systematic approach to modernization. It's not just a model, I mean, not just for modernization. I think any problem that we take, this notion of, okay, LLMs will solve all for you is something where I see a lot of people coming in like, okay, we could do this, okay, we could do that. Yes, you can build prototypes. Yes, you can show some initial proof of concept. But when we are looking at enterprise scale, and in fact, it's a business critical applications, you can't be taking that risks. We should leverage LLMs. We should leverage the deterministic tools, ensure that it is repeatable, and ensure that the end application is secure. Have the human in the loop for all the validation that needs to be done. And that's how we successfully transform an application, like a legacy application, into a modern application that is ready for your next gen of customers or next gen of APIs, and also your database or data platform being ready for your agentic AI applications for future.
And for teams who are shopping around for a persistence layer, whether for a generalized use case or for a specific purpose, such as vectors, what are the cases where Mongo is the wrong choice?
Yeah, so MongoDB supports a variety of use cases, and we are positioned as a unified data platform for your operational DB, for real time analytics on that operational data, for as a graph DB, as a database which supports time series data, so you can handle events with Atlas search and vector embeddings evolve into that context memory area and so on. So we are there most of the places where our customers need. But if you ask me, like, okay, there is one place where it would I would consider something else. I think if customers are looking for a generic data backend for analytics, that's where I would say maybe there are other choices that should be considered.
And as you continue to invest in the AMP product and work with customers who are migrating to the MongoDB platform, what are some of the use cases or projects or problem areas that you're excited to explore in the near to medium term?
So we have spent the last couple of months in code transformation, specifically looking at the stored procedures, converting them to application layer business logic. I think we have a very good understanding of very good set of tools for our code transformation, applications transformation, moving the business logic from the data layer to the application layer, orchestrating all of it, having the right APIs and interfaces, and so on. Today, it is done through a tool chain with technique involved, with people, experts who actually come and help the customers, with some of the variations that one might have seen because of 2 3 decades of evolution of these legacy applications. What I look forward to in future would be taking as many of these steps where there is human in the loop to convert it into multiple different agents which work together. Yes, there are certain steps where we will still need humans for governance checks and security approvals and so on, but there are many aspects that we are looking at converting the steps that were earlier done with human in the loop by having multiple agents interact with each other, having an agent that does the critique of the steps that the previous agents took, and so on. That is something that I'm looking forward to.
Are there any other aspects of the work that you're doing on the MongoDB application modernization platform that we didn't discuss yet, or use cases that it enables that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think we covered most aspects of AMP and what how it helps our customers modernize and onboard onto MongoDB, which in turn will help them be ready for future changes. I'm super excited about what the team has built so far and what the team has achieved so far, and looking forward to more capabilities that we will put forward in front of the customers.
Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
The biggest gap. I think things are changing very fast. I wouldn't call it as gap. I would call gap in today's data management tooling. It's basically our evolution. So I feel that with the in the AI world, the way we treated data changes drastically. It's more about what is in that data, the meaning of that data. And database systems have been more about like, system of record. Like here is an action that happened. They recorded what rather than why. And this change from what to why would be a big change for our data management overall, right? If an action was taken, then we looked at it saying that, okay, this action was taken on this data. This you deducted $100 from this account, and that was it. And we had a version ID and said, okay, previous version had $200, the next version has $100 deducted, and it's only $100. And that worked really well for us till now. But in the AI world, the application is not static. The agents are not static. They are also evolving and updating themselves. So just having noting down that, okay, there was this change, what changed is not sufficient. We'll have to look at what changed, why it changed, what was the reasoning behind it, and what was the context behind it. So a simple thing like versioning now becomes a complex problem. And something that was cheaper earlier, like, okay, just put a version number. Now you'll have to have all of the context around that. And earlier you just needed to know what was the application's current binary release number because it's always deterministic, and now things are changing drastically. So I think simple problems like versioning will need to evolve, and then the scale at which we handle the data will need to evolve. because now we are not, and the latency also, like the latency at which you read and write data also is evolving, because we are not thinking like earlier it'll be like, okay, yeah, human will interact with the application, it's okay for it to be in milliseconds or seconds. But now, with agents running your workload or taking the decisions for you or taking the action for you, I think that real timeness, the definition of how real time is drastically changing. And I believe that all of the data stores and data management systems should evolve to those needs.
All right. Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on the AMP product for MongoDB and the different use cases that it enables and how it's leveraging the feature set and functionality that Mongo has spent the past decade plus working on evolving. So thank you again for all the time and effort you are putting into that. I hope you enjoy the rest of your day.
Thank you, Tobias.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.